Article 406.8 of the National Electrical Code requires that ground fault circuit interrupter protection for outdoor outlets must extend at least 6 feet beyond the exterior wall or to the property line, whichever is less. Article 350.18b requires that raceways, also known as conduits, used for outdoor installations must be approved for wet locations and be weatherproof. Thin wall electrical metallic tubing, abbreviated EMT, is not considered weatherproof. Based on these two articles, an installation with a ground fault circuit interrupter outlet on a covered porch using thin wall EMT is not legal. To correct this situation, firstly, extend the ground fault circuit interrupter protection inside the house. This involves installing a ground fault circuit interrupter outlet or a ground fault circuit interrupter circuit breaker at the first outlet inside the house, effectively moving the point of protection upstream from the outdoor location. Secondly, replace the electrical metallic tubing with a weatherproof conduit. Acceptable alternatives include polyvinyl chloride conduit, often abbreviated as polyvinyl chloride, or rigid metal conduit, often abbreviated as rigid metal conduit. These conduits are designed to withstand wet conditions and provide adequate protection for the electrical conductors. Thirdly, ensure that all conduit penetrations are properly sealed. This means using watertight connectors or sealant at all points where the conduit enters or exits boxes or enclosures. This prevents moisture from entering the system and causing corrosion or electrical faults. Fourthly, verify that the outdoor box is weatherproof and rated for the specific location. Outdoor electrical boxes must be designed to prevent water from entering and damaging the electrical components inside. The electrical box needs to have an appropriate ingress protection rating. An ingress protection rating, often displayed as IP followed by 2 digits, indicates the degree of protection provided by an enclosure against solid objects and liquids. The first digit represents the level of protection against solid objects, ranging from 0 to 6, with higher numbers indicating greater protection. The second digit represents the level of protection against liquids, ranging from 0 to 9, with higher numbers indicating greater protection. For example, an IP65 rating signifies that the enclosure is dust-tight, protected against dust ingress, and protected against water jets projected from any direction. When selecting an electrical box for outdoor use, carefully consider the specific environmental conditions to which it will be exposed, such as rainfall, humidity, and potential for submersion. An electrical enclosure that is listed as NEM 3R is intended for outdoor use and provides a degree of protection against rain, sleet, snow, and the formation of ice. This is a common rating for junction boxes, disconnects, and other electrical components installed outdoors. NEMA is an acronym for the National Electrical Manufacturers Association. A NEMA 4 enclosure offers a higher level of protection compared to a NEMA 3R enclosure. NEMA 4 enclosures are designed to be watertight, preventing the ingress of water from splashing hose-directed water and even temporary submersion. These enclosures are commonly used in applications where equipment is exposed to harsh outdoor conditions or where frequent washdowns are required. NEMA 4X enclosures provide the same level of protection as NEMA 4 enclosures but offer enhanced corrosion resistance. They are typically constructed from stainless steel, fiberglass, or other non-corrosive materials, making them suitable for use in corrosive environments such as coastal areas, chemical plants, and food processing facilities. The selection of an NEMA 4X enclosure ensures long-term reliability and protection against corrosion-related failures in demanding applications. An additional consideration is that the LB conduit body should also be weatherproof to maintain the integrity of the conduit system. Although compression fittings are not specifically required for weatherproofing, they can provide an added layer of protection against moisture ingress. It is crucial to involve a licensed electrician to perform the necessary work to ensure that it is done safely and correctly. A licensed electrician has the knowledge, skills, and experience to identify potential hazards, comply with all applicable codes and regulations, and ensure that the electrical system is installed and maintained in a safe and reliable manner. Engaging a licensed electrician not only ensures compliance with legal requirements but also provides peace of mind knowing that the electrical work is performed by a qualified professional. They can assess the specific conditions of the installation, recommend appropriate solutions, and execute the work with precision and attention to detail, minimizing the risk of electrical hazards and ensuring the long-term performance of the electrical system. Electrical metallic tubing, also known as EMT, is a type of rigid metal conduit commonly used for protecting electrical wiring. It is typically made of galvanized steel or aluminum and is available in various sizes and lengths to accommodate different wiring needs. EMT is a popular choice for both residential and commercial electrical installations due to its affordability, ease of installation, and ability to provide mechanical protection to the enclosed wiring. One of the key advantages of electrical metallic tubing is its lightweight construction, which makes it easy to handle and install, especially in tight spaces or overhead applications. The smooth interior surface of EMT also facilitates the pulling of wires through the conduit, reducing the risk of damage to the insulation. Electrical metallic tubing is typically joined together using fittings such as couplings and connectors, which are secured with set screws or compression rings. These fittings create a secure and reliable connection between sections of the conduit, ensuring the continuity of the electrical raceway. EMT is commonly used in exposed locations, such as along walls or ceilings, as well as concealed within walls or floors. However, it is important to note that electrical metallic tubing is not suitable for use in certain environments, such as wet or corrosive locations, unless it is specifically listed and labeled for such applications. In these cases, other types of conduit, such as polyvinyl chloride or rigid metal conduit, may be more appropriate. While electrical metallic tubing provides mechanical protection to the enclosed wiring, it is not considered a grounding conductor. Therefore, a separate grounding conductor must be installed within the conduit to provide a path for fault current in the event of a short circuit. The grounding conductor is typically connected to the metal enclosure of the electrical equipment and the grounding busbar in the electrical panel, ensuring that the system is properly grounded. When installing electrical metallic tubing, it is important to follow all applicable codes and regulations, such as the National Electrical Code, to ensure that the installation is safe and compliant. This includes properly supporting the conduit, using the correct fittings, and ensuring that the wiring is properly sized and protected. Failure to comply with these requirements can result in electrical hazards, such as shocks, fires, and equipment damage. In addition to its use in electrical wiring systems, electrical metallic tubing is also commonly used for other applications, such as telecommunications, data networking, and control systems. Its versatility and ease of installation make it a popular choice for a wide range of electrical and electronic applications. When selecting electrical metallic tubing for a specific application, it is important to consider factors such as the size and type of wiring to be enclosed, environmental conditions, and the applicable codes and regulations. By carefully considering these factors, it is possible to choose the right type of EMT to ensure a safe and reliable electrical installation. Rigid metal conduit is a type of heavy-duty conduit commonly used for protecting electrical wiring in harsh or demanding environments. It is typically made of steel or aluminum and is characterized by its thick walls and threaded ends. Rigid metal conduit provides superior mechanical protection compared to electrical metallic tubing, making it suitable for applications where the wiring is exposed to physical damage or abuse. One of the key advantages of rigid metal conduit is its ability to withstand significant impact, crushing, and bending forces. This makes it ideal for use in industrial facilities, construction sites, and other environments where the wiring is at risk of being damaged. Rigid metal conduit is also resistant to corrosion, making it suitable for use in wet or corrosive locations. The threaded ends of rigid metal conduit allow for secure and reliable connections to fittings and enclosures. These connections are typically made using threaded couplings and connectors, which provide a watertight and corrosion-resistant seal. Rigid metal conduit is commonly used in both exposed and concealed locations, depending on the specific requirements of the installation. It can be installed along walls, ceilings, or floors, or buried underground, providing protection to the enclosed wiring in a variety of environments. When installing rigid metal conduit, it is important to properly support the conduit to prevent sagging or damage. This is typically done using conduit hangers or straps, which are attached to the building structure. The spacing between supports depends on the size and type of conduit, as well as the applicable codes and regulations. In addition to providing mechanical protection, rigid metal conduit also serves as a grounding conductor. The metal conduit provides a continuous path for fault current to flow back to the source, ensuring that the electrical system is properly grounded. This helps to prevent electrical shocks and fires in the event of a short circuit. When selecting rigid metal conduit for a specific application, it is important to consider factors such as the size and type of wiring to be enclosed, the environmental conditions, and the applicable codes and regulations. It is also important to choose the right type of fittings and accessories to ensure a secure and reliable installation. Rigid metal conduit is available in various sizes and lengths to accommodate different wiring needs. It is typically sold in 10-foot lengths, but can be cut and threaded to the desired length using a pipe cutter and threader. When cutting and threading rigid metal conduit, it is important to use the proper tools and techniques to ensure that the threads are clean and accurate. Polyvinyl chloride conduit, commonly abbreviated as polyvinyl chloride, is a type of non-metallic conduit widely used for protecting electrical wiring in a variety of applications. It is made from a rigid plastic material that is lightweight, durable, and resistant to corrosion. Polyvinyl chloride conduit is a popular choice for both residential and commercial electrical installations due to its affordability, ease of installation, and versatility. One of the key advantages of polyvinyl chloride conduit is its resistance to corrosion. Unlike metal conduits, polyvinyl chloride conduit will not rust or corrode when exposed to moisture, chemicals, or other corrosive substances. This makes it ideal for use in wet or damp locations, as well as environments where the wiring is exposed to corrosive fumes or liquids. Polyvinyl chloride conduit is also lightweight and easy to handle, making it easier to install than metal conduits. It can be cut to the desired length using a saw or tubing cutter, and joined together using fittings such as couplings and elbows. The fittings are typically attached to the conduit using cement or solvent welding, creating a strong and watertight connection. Polyvinyl chloride conduit is available in various sizes and types to accommodate different wiring needs. It is typically classified by its schedule, which indicates the wall thickness and pressure rating of the conduit. Schedule 40 polyvinyl chloride conduit is the most common type and is suitable for a wide range of applications. Schedule 80 polyvinyl chloride conduit has a thicker wall and is designed for use in more demanding applications such as underground or direct burial installations. When installing polyvinyl chloride conduit, it is important to properly support the conduit to prevent sagging or damage. This is typically done using conduit hangers or straps, which are attached to the building structure. The spacing between supports depends on the size and type of conduit, as well as the applicable codes and regulations. Polyvinyl chloride conduit is not a grounding conductor, so a separate grounding conductor must be installed within the conduit to provide a path for fault current in the event of a short circuit. The grounding conductor is typically connected to the metal enclosure of the electrical equipment and the grounding busbar in the electrical panel, ensuring that the system is properly grounded. When selecting polyvinyl chloride conduit for a specific application, it is important to consider factors such as the size and type of wiring to be enclosed, the environmental conditions, and the applicable codes and regulations. It is also important to choose the right type of fittings and accessories to ensure a secure and reliable installation. Polyvinyl chloride conduit is commonly used in a variety of applications, including residential wiring, commercial wiring, underground wiring, and industrial wiring. Its versatility and ease of installation make it a popular choice for a wide range of electrical and electronic applications. In addition to its use in electrical wiring systems, polyvinyl chloride conduit is also commonly used for other applications such as telecommunications, data networking, and control systems. Its resistance to corrosion and its ability to be easily modified make it a popular choice for these applications. When working with electrical systems, safety is paramount. Always de-energize the circuit before beginning any work. This can be accomplished by turning off the appropriate circuit breaker or removing the fuse that supplies power to the circuit. Verify that the circuit is energized by using a voltage tester to check for the presence of voltage at the wires or terminals. Before starting any electrical work, it is essential to wear appropriate personal protective equipment to minimize the risk of injury. This includes safety glasses or goggles to protect the eyes from flying debris or accidental contact with the electrical components. Wear insulated gloves to protect your hands from electric shock. Rubber-soled shoes or boots can help to insulate you from the ground and reduce the risk of electric shock. When working with electrical tools, it is important to use tools that are properly insulated and in good working condition. Inspect your tools before each use to ensure that the insulation is intact and that there are no signs of damage or wear. Use tools that are specifically designed for electrical work, such as insulated screwdrivers, pliers, and wire strippers. Never use tools that are not properly insulated or that are damaged, as this can increase the risk of electric shock. When working with electrical wiring, it is important to follow all applicable codes and regulations, such as the National Electrical Code. These codes provide detailed guidelines for the safe and proper installation of electrical wiring systems. Familiarize yourself with the applicable codes and regulations before beginning any electrical work, and ensure that your work complies with these requirements. When making connections to electrical terminals, it is important to ensure that the connections are tight and secure. Loose connections can cause overheating, arcing, and electrical fires. Use a torque screwdriver to tighten screws and terminals to the manufacturer's specified torque value. Check connections periodically to ensure that they remain tight and secure. When working with electrical panels, it is important to be aware of the potential hazards associated with working around live electrical components. Never touch any exposed wires or terminals inside the panel, as this can result in electric shock. Use insulated tools and wear appropriate personal protective equipment when working inside the panel. If you are not comfortable working inside an electrical panel, it is best to call a qualified electrician to perform the work. When working with electrical circuits, it is important to be aware of the potential for overloading the circuit. Overloading a circuit can cause the circuit breaker to trip, or worse, can result in overheating and electrical fires. Avoid plugging too many appliances or devices into a single circuit, and ensure that the total load in the circuit does not exceed the circuit's rated capacity. If you are unsure of the circuit's capacity, consult a qualified electrician. When working with electrical equipment, it is important to follow the manufacturer's instructions for safe operation. Read the instruction manual carefully before using any electrical equipment, and follow all safety precautions. Never use electrical equipment in a way that is not intended by the manufacturer, as this can increase the risk of injury or damage. When working with electrical systems, it is important to be aware of the potential for electrical fires. Electrical fires can be caused by a variety of factors, such as short circuits, overloaded circuits, and loose connections. If you detect the smell of burning plastic or see sparks or smoke coming from an electrical outlet or appliance, immediately turn off the power to the circuit and call the fire department. Keep a fire extinguisher nearby when working with electrical systems, and know how to use it properly. When working with electrical systems, it is important to be aware of the potential for electric shock. Electric shock can occur when you come into contact with a live electrical wire or component. The severity of the shock depends on the voltage, the current, and the duration of the contact. Electric shock can cause burns, muscle spasms, cardiac arrest, and even death. If someone is being electrocuted, do not touch them directly. Use a non-conductive object, such as a wooden broom handle, to separate them from the source of electricity. Call for emergency medical assistance immediately. Always remember that safety should be of top priority when working with electrical systems. Take the time to plan your work carefully, use the proper tools and equipment, and follow all applicable codes and regulations. If you are not comfortable performing electrical work yourself, it is best to call a qualified electrician to do the job. The ground fault circuit interrupter is a crucial safety device designed to protect people from electrical shock. It works by monitoring the current flowing through a circuit and quickly interrupting the power if it detects an imbalance, indicating that current is leaking to ground. This leakage current, even a small amount, can be extremely dangerous and potentially fatal. The ground fault circuit interrupter is designed to trip or interrupt the circuit when it detects a ground fault. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. This can happen if someone touches a live wire or a faulty appliance with a grounded surface. The ground fault circuit interrupter constantly monitors the current flowing through the hot and neutral wires in a circuit. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance between the hot and neutral currents. The ground fault circuit interrupter is designed to detect even small imbalances in current, typically around 5 milliamps. When it detects an imbalance above this threshold, it quickly trips the circuit, interrupting the power and preventing electric shock. The ground fault circuit interrupter works very quickly, typically tripping the circuit within a fraction of a second. This rapid response time is crucial in preventing serious injury or death from electric shock. The ground fault circuit interrupter is required by electrical codes in many locations, particularly in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. It is typically installed in outlets, circuit breakers, and portable power cords. There are two main types of ground fault circuit interrupters: outlet ground fault circuit interrupters and circuit breaker ground fault circuit interrupters. Outlet ground fault circuit interrupters are installed in individual electrical outlets and protect only the outlets on that circuit. Circuit breaker ground fault circuit interrupters are installed in the electrical panel and protect the entire circuit. To test a ground fault circuit interrupter, simply press the test button on the device. This simulates a ground fault and should cause the ground fault circuit interrupter to trip, interrupting the power to the circuit. To reset the ground fault circuit interrupter, press the reset button. If the ground fault circuit interrupter does not trip when you press the test button, or if it trips frequently for no apparent reason, it may be faulty and should be replaced by a qualified electrician. The ground fault circuit interrupter is a life-saving device that can protect you and your family from electric shock. Make sure that your home is equipped with ground fault circuit interrupters in all areas where they are required by code, and test them regularly to ensure that they are functioning properly. Regular testing and maintenance of ground fault circuit interrupters are essential to ensure their continued effectiveness. It is recommended to test ground fault circuit interrupters at least once a month or more frequently if they are located in areas where they are exposed to moisture or other harsh conditions. In addition to testing, it is also important to visually inspect ground fault circuit interrupters for any signs of damage or wear. Look for cracks, discoloration, or other signs of deterioration. If you notice any damage, replace the ground fault circuit interrupter immediately. When replacing a ground fault circuit interrupter, it is important to choose a replacement that is compatible with your electrical system. Make sure that the replacement ground fault circuit interrupter has the same voltage and amperage rating as the original, and that it is listed by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. Installation of a ground fault circuit interrupter should be performed by a qualified electrician. Electrical work can be dangerous, and it is important to have the work done by someone who is trained and experienced. A qualified electrician will ensure that the ground fault circuit interrupter is properly installed and that it is functioning correctly. Ground fault circuit interrupters are not foolproof, and they will not protect you from all electrical hazards. However, they provide a significant level of protection against electric shock, and they are an essential safety device in any home or business. By understanding how ground fault circuit interrupters work and by taking steps to ensure that they are properly installed and maintained, you can help to protect yourself and your family from electrical shock. An LB conduit body is a type of electrical fitting used to provide access to conductors within a conduit system. The LB designation refers to the shape of the fitting, which resembles an L with a removable cover. LB conduit bodies are commonly used to make 90-degree bends in conduit runs, allowing for easy access to pull wires and make connections. The primary purpose of an LB conduit body is to provide a convenient access point for pulling wires through conduit. The removable cover allows electricians to easily insert and remove wires without having to disassemble the entire conduit system. This is particularly useful in long conduit runs or in areas where there are multiple bends. LB conduit bodies are typically made of aluminum or galvanized steel and are available in various sizes to accommodate different conduit sizes. They are designed to be weatherproof or rain-tight, making them suitable for both indoor and outdoor applications. When selecting an LB conduit body, it is important to choose the correct size to match the conduit being used. The LB conduit body should also be made of a material that is compatible with the environment in which it will be installed. For example, in corrosive environments, it is important to use an LB conduit body made of corrosion-resistant material such as stainless steel or fiberglass. Installation of an LB conduit body is relatively simple. The conduit is connected to the LB conduit body using threaded or threadless fittings. The cover is then secured to the LB conduit body using screws or bolts. When installing an LB conduit body, it is important to ensure that the cover is properly sealed to prevent moisture from entering the conduit system. This is typically done using a gasket or sealant. LB conduit bodies are commonly used in a variety of electrical applications, including residential, commercial, and industrial wiring systems. They are particularly useful in situations where there are multiple bends in the conduit run or where access to the wires is required for maintenance or repairs. In addition to providing access to wires, LB conduit bodies can also be used to support conduit runs. The LB conduit body can be attached to a wall or ceiling using mounting brackets or straps. When using an LB conduit body to support conduit, it is important to ensure that the mounting brackets or straps are properly sized and installed to support the weight of the conduit and wires. LB conduit bodies are an essential component of many electrical wiring systems. They provide a convenient access point for pulling wires, making connections, and supporting conduit runs. By understanding the purpose and function of LB conduit bodies, electricians can ensure that their wiring systems are safe, reliable, and easy to maintain. When working with electrical systems, it is always important to follow all applicable codes and regulations. This includes using the correct materials, installing the equipment properly, and ensuring that the system is properly grounded. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. An electrical box is an enclosure designed to protect electrical connections and provide a safe mounting point for electrical devices such as switches, receptacles, and light fixtures. Electrical boxes are an essential component of any electrical wiring system, providing a secure and organized way to house and protect electrical connections. Electrical boxes are typically made of metal or plastic and come in a variety of shapes and sizes to accommodate different wiring configurations and device types. Metal boxes are typically made of steel or aluminum and are used in applications where durability and fire resistance are important. Plastic boxes are typically made of polyvinyl chloride or fiberglass and are used in applications where corrosion resistance is important. Electrical boxes are classified by their size, shape, and construction type. Common types of electrical boxes include square boxes, rectangular boxes, round boxes, and octagonal boxes. The size of the box is determined by the number of wires and devices that need to be accommodated within the box. Electrical boxes are also classified by their construction type, such as surface mount boxes, flush mount boxes, and weatherproof boxes. Surface mount boxes are mounted directly on the surface of a wall or ceiling. Flush mount boxes are recessed into the wall or ceiling and are used with devices that are designed to be flush with the wall or ceiling surface. Weatherproof boxes are designed to protect electrical connections from moisture and other environmental factors and are used in outdoor applications. When selecting an electrical box, it is important to choose the correct size and type to accommodate the wiring and devices that will be installed in the box. The box should also be made of a material that is compatible with the environment in which it will be installed. For example, in wet or damp locations, it is important to use a weatherproof box made of corrosion-resistant material. Installation of an electrical box is relatively simple. The box is attached to a wall or ceiling using screws or nails. The wires are then connected to the devices within the box using wire connectors. When installing an electrical box, it is important to ensure that the box is properly grounded to prevent electrical shock. The grounding wire is typically connected to the metal box using a grounding screw or clip. Electrical boxes are an essential component of any electrical wiring system. They provide a safe and organized way to house and protect electrical connections and devices. By understanding the different types of electrical boxes and their applications, electricians can ensure that their wiring systems are safe, reliable, and compliant with all applicable codes and regulations. When working with electrical systems, it is always important to follow all applicable codes and regulations. This includes using the correct materials, installing the equipment properly, and ensuring that the system is properly grounded. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. A licensed electrician possesses the knowledge, skills, and experience necessary to safely and effectively install and maintain electrical systems. Hiring a licensed electrician ensures that the work is performed in compliance with all applicable codes and regulations, reducing the risk of electrical hazards and ensuring the long-term safety and reliability of the electrical system. Licensed electricians undergo extensive training and testing to demonstrate their competence in electrical work. They are knowledgeable about electrical theory, wiring methods, and safety procedures. They are also familiar with the National Electrical Code and other applicable codes and regulations. Hiring a licensed electrician provides peace of mind knowing that the work is being performed by a qualified professional. Licensed electricians are required to carry insurance, which protects homeowners from liability in the event of an accident or injury. They are also required to warranty their work, providing assurance that any defects or problems will be corrected at no additional cost. Licensed electricians can perform a wide range of electrical services, including new construction wiring, electrical repairs, electrical upgrades, and electrical inspections. They can also provide advice on energy-efficient lighting and electrical systems. When hiring a licensed electrician, it is important to check their credentials and references. Verify that they are licensed and insured, and ask for references from previous customers. It is also a good idea to get multiple bids from different electricians before making a decision. Hiring a licensed electrician is an investment in the safety and reliability of your electrical system. It is a decision that can save you money and headaches in the long run. By hiring a qualified professional, you can ensure that your electrical work is done right the first time and that your electrical system is safe and compliant with all applicable codes and regulations. Electrical safety is of utmost importance, and it is never worth taking risks when it comes to electrical work. If you are not comfortable performing electrical work yourself, or if you are unsure about any aspect of the work, it is always best to call a licensed electrician. They can provide expert advice and perform the work safely and effectively. Electrical work is not a do-it-yourself project. It requires specialized knowledge, skills, and equipment. Hiring a licensed electrician is the best way to ensure that your electrical work is done safely and correctly. The National Electrical Code, often abbreviated as National Electrical Code, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. It is developed and published by the National Fire Protection Association and is updated every 3 years to reflect changes in technology and best practices. The National Electrical Code is widely adopted by state and local governments as the basis for their electrical codes. It provides a uniform set of rules and regulations that help to ensure the safety of people and property from electrical hazards. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for the selection, installation, and maintenance of electrical equipment and wiring systems. The purpose of the National Electrical Code is to protect people and property from electrical hazards. It establishes minimum safety standards for electrical installations and helps to prevent electrical shocks, fires, and other electrical accidents. The National Electrical Code is not a design manual. It does not tell electricians how to design electrical systems. Instead, it provides minimum safety requirements that must be met when designing and installing electrical systems. The National Electrical Code is a living document that is constantly being revised and updated to reflect changes in technology and best practices. The National Fire Protection Association solicits input from experts in the electrical industry and from the public when developing revisions to the National Electrical Code. The National Electrical Code is an essential resource for electricians, electrical contractors, and electrical inspectors. It provides the information they need to ensure that electrical installations are safe and compliant with all applicable codes and regulations. The National Electrical Code is also a valuable resource for homeowners and business owners who want to understand the basics of electrical safety. By understanding the National Electrical Code, they can take steps to protect themselves and their property from electrical hazards. The National Electrical Code is a complex and comprehensive document. It is important to consult the National Electrical Code directly for specific requirements and guidance. There are also many resources available to help electricians and others understand the National Electrical Code, including training courses, seminars, and online forums. The National Electrical Code is an important tool for promoting electrical safety. By following the National Electrical Code, electricians and others can help to prevent electrical accidents and ensure that electrical installations are safe and reliable.